Hello and welcome to this tutorial on how to use the auto-tuning tool for controller optimization. In the following I will show you how easy it is to optimize the controller with this tool in the Easy Starter, also in comparison to another method for controller optimization that is already included in the Easy Starter. When we open the inverter in the Easy Starter, we start with this user interface. From there we can go to the Settings tab, and from there we can select the different setting categories in the drop-down menu. Before we can start with the controller setting, we must make sure that in the Easy Starter the basic settings for our system are correct. So, check the settings for the kinematics, motor, brake, and encoder. I have already checked this and therefore switch directly to the motor control. In this interface you will find the controller setting, namely the position controller gain, and the speed controller gain and reset time. We have for this default values based on the motor, listed here on the left, and actual values that are currently set. To accept the default values as actual values, we can click on this arrow in the middle here. At the top there is a slider with which the load can be varied. According to the set load, the default values of the controller change, but currently not the actual values. We can change this by switching to Immediate Apply here. If we move the slider now, the controller setting changes directly. Whether the current setting causes stable or unstable behavior is shown here. Now we need to set the load slider back to 0 in preparation for the actual controller calibration. For this we must start a cyclic movement at the test stand. Such a movement can be defined in the Easy Starter in the Profiles tab or as here, started via a separate program. To get a better understanding of the behavior at the test stand during the controller adjustment, we will look at it in various traces. At the top, the following error is displayed, followed by the positions, with the set point and actual position displayed one above the other. Below this, the same applies to speeds, and in the last position the torque is shown. As soon as the movement is started, the trace starts recording. After that, you can start moving the slider slowly until an instability is reached. This can generally be seen on the indicator and in the trace, but can also be heard. The slider should then be reduced to about half again. This position then represents a good slider optimization. The resulting controller parameters can then be read from the actual values. After successful setting, the movement can now be ended, and if wished, the trace can be viewed in more detail. It can be seen that the following error quickly drops significantly when the load is increased and only noticeably increases again during instability. Similar noise can also be seen in the speed and especially in the torque during instability. With final controller setting, this example results in a maximum following error of about 0.01. Alternatively to this procedure, the auto-tuning tool can be used to perform an automated and optimized controller optimization. We get to the user interface of the auto-tuning process by clicking on Optimization. Alternatively, you can also navigate to the Optimization tab. In this user interface, you will first find a few general notes, but they have already been followed in the current procedure. Below this, we find the parameters for the motion profile. The form of the profile is shown on the right as a picture and corresponds to a similar cyclic motion as we have already used in the last procedure. Regarding the profile parameters, we again have default and actual values and a button to apply them. In this case, we have increased the default values by a factor of 10 each to create a more significant movement. Under the profile settings you will again find the controller settings in the form of gain and reset time for the speed controller and the position controller gain. Due to the fact that the motion profile is integrated in the execution here, one click on the Start button is enough to start both the motion and the optimization. After startup, it first goes through a short initialization phase before it starts optimizing the speed controller gain. The progress can be seen in the change of the value here. If for some reason you want to cancel the optimization, it is possible at any time with this button. Now the auto-tuner gradually finds the optimal setting for the different controller parameters. It always has to find the stability limits, which is why the current parameter is always increased slowly. All in all, this process can take a few minutes, which is why we will show it below in fast forward. After the successful optimization of the speed controller gain, we move on to the optimization of the reset time, which we can observe using this value. Last but not least is the optimization of the position controller gain. After successful optimization of the position controller gain, the auto-tuning process ends, and the result is summarized in a short statement. So in this case the performance has been improved, which is virtually always the case in the first run. The optimized controller parameters are now displayed below here. A look at the trace shows that once again a significant reduction in the tracking error was achieved very quickly. This time, a maximum tracking error of 0.005 is achieved as the best value. Compared to the last design, the value was thus halved. Moments of instability during optimization are again very clearly visible in the torque. In principle, this concludes the presentation of the auto-tuner. This automated optimization is a simplified, user-friendly alternative to optimization by load slider. Not only has the necessary user interaction been reduced to the push of a button, but the result has also been improved, here proven by the reduced following error. However, as an additional step, we would like to show what happens when the optimization is repeated. We are particularly interested in whether an identical performance is achieved or whether an improvement or a degradation occurs. We will look at this run of the auto-tuner again in fast forward. The second run also works perfectly and as expected. Identical performance was achieved. The values of the controller parameters are also largely identical, except for the position controller gain, which is minimally smaller this time. However, this is a marginal difference for this system, so that an identical performance can be expected. This brings us to the end of this tutorial. I hope all your questions about the function and use of the auto-tuning tool in Easy Starter have been answered, so that nothing stands in the way of its successful use.